Okay, so we're doing inverse trig functions today, 6.2. Obviously, you want to pause this whenever you need to, and then I'll explain it as best I can. So inverse trig functions, it's basically what we've been doing, but we're going to do it a couple different ways. So we're going to find exact values, and then example 1, we're going to do inside-out method. So you actually already know this method. So let's say for A, you have cosine inverse of the sine of something. So what I do is I use a little unit circle to find the sine of 5 pi over 4. The sine of 5 pi over 4, I think about it is, and then I use my left hand, negative root 2 over 2. And then the cosine inverse of negative root 2 over 2, well, cosine inverse has to be in quadrant 1 or 2. So then I think, where does this happen for cosine? Either here or here. And in this case, it must be here. So then my final answer is 3 pi over 4. So same as we've been doing. Okay, one more, like that. So B, sine inverse of cosine of 2 pi over 3. So cosine of 2 pi over 3, I draw myself a little unit circle. I think about 2 pi over 3 is right here. And then the cosine is, I use my left hand, negative 1/2. So then the question is, where does sine give you negative 1/2? Well, that's going to have to be negative y values. Negative 1/2 for sine is either here or here. And then if this is my range for sine inverse, then I have to either be in quadrant 1 or quadrant 4, so it must be this answer. So I started with this one, and I went, okay, where is sine negative? So it's got to be here, here. Sine negative 1/2 is here, here. And then I use my range to get this answer. I cannot call that, what would that be, 11 pi over 6? Because that's too big, so instead I call it negative pi over 6. Okay, so that's inside out. That's something that we've already been doing. So the next one is new. So example 2, we're going to be using a sketch. So using a sketch because it's not on the unit circle. So when you do it, you're going to be like, oh, that's weird. So then you're going to see like arc cosine of something that's not on the unit circle. So if it's not on the unit circle, really an arc cosine or a cosine inverse, this whole thing, I'm going to go like this. This whole thing represents a theta. So theta, I don't know what it is, but I can represent it with a picture. How I do this picture is I know that cosine inverse is negative. That's in quadrant 2. So quadrant 2, I draw myself a little triangle. My negative 3 goes on the x-axis. My 5 is my hypotenuse. I think about what's this going to be, 3, 4, 5 triangle, or I can use Pythagorean Theorem. So 3 squared plus what equals 5 squared. Okay? So then I use this picture as my theta, and then once I have the picture, I'm just finding the sine of theta, and the sine of theta, the sine of this theta, is 4 over 5, opposite over hypotenuse. So this represents theta, that whole thing, and then I get the sine of theta, which is this. Okay, I'm going to do that again for this one. The tangent of sine inverse. So sine inverse, for it to be negative, I'm in quadrant 4. So from quadrant 4, I go ahead and draw my triangle. I always have a right angle on my x-axis, and then I always have theta coming from the origin. So my negative 2 is on my y-axis because this is sine opposite over hypotenuse. So my opposite is negative 2, my hypotenuse is 3, and then I think of my Pythagorean Theorem, and I get root 5 over here, positive root 5, because this is in quadrant 4. So my theta is represented by this picture, and once I have the picture, I can get the tangent of theta, and the tangent of theta is opposite over adjacent, so negative 2 over root 5, which is the same as negative 2 root 5 over 5. Okay, so one more, but a little bit trickier. I'm not going to highlight this time. So the sine of arc cosine of x. All right, so again, I'm going to rewrite this as cosine of theta equals, and technically this is a fraction, so you'll see why I want this to be a fraction in a second. But this is a fraction, so I'm going to write x over 1. And then I need to draw my theta. So this is in quadrant 1 as far as I know. It's, positive. It's positive in front of the x. So then in quadrant 1, I draw a triangle. My x is the x value. My 1 is the hypotenuse, right? Because I need to be adjacent over hypotenuse, or this needs to be x over r. So here's my x, and here's my hypotenuse, or my radius. And then how did I get this? Pythagorean Theorem. So x squared plus this equals 1. So this must be the square root of 1 minus x squared. So you can do the Pythagorean Theorem and write it out nicely, but you're going to get this in the end. So now, using this theta, the sine of theta, the sine of the whole thing means the sine of theta equals opposite over hypotenuse, which is just the radical. All right, so the next one is trickiest one, D. So for D, the cotangent of the sine inverse of 3x. So again, I start with sine of theta equals 3x. This is technically 3x over 1, so opposite is 3x, and then hypotenuse is 1. My opposite is 3x, my hypotenuse is 1. I do a squared plus b squared equals c squared, and then I get the square root of 1 minus 9 squared. If you do this on your own, what a lot of people do is they write 3x squared because they forget to square the 3. So it's really 9x squared. Okay, so then I do cotangent of this. The cotangent is x over y. So x over y is just going to be that. Done. Okay. So then the next part is we're going to do the same kind of thing, but using reciprocals. So reciprocals are going to be, can I fit it? Yeah, there we go. So reciprocals meaning, you know that the secant of something is the same as the 1 over cosine of something. And then this part is a little bit different. So secant inverse, this is the answer, right? So like inverses, instead of the x, this is like the answer, this is the y. So if I have the answer, then cosine inverse is going to be the reciprocal. So you can think of it as like if cosine is 1/2, then secant would be 2, right? So if cosine is 1/2, then secant would be 2. So that's why if it's the answer, I just flip the answer, and then I get my cosine inverse. So realize that this is true now. And then 3 more ranges to remember. So it seems like a lot, but the first 2 are really easy to remember. So the first one, if y equals secant inverse of x, so secant is 1 over cosine. You can see this is the same range as cosine inverse. So no big deal. This is true. This is because we had, like when you draw secant, don't you have a bunch of u's and n's? So then you end up with a bunch of vertical asymptotes. So this is true, but I'm not going to trick you with this. I'm not really going to ask you about this. This is the part that I want you to remember. Okay? Cosecant inverse, the range, is the same as 1 over cosecant, which is sine inverse. So that one's really easy to remember. Again, I'm not going to try to trick you with this, but it's true, so you don't have to write it down. Okay, the third one, that's the one that's tricky to remember. It's not tricky to remember, but it's tricky to like remember that you have to use it. So cotangent inverse, the range is not the same as tangent inverse. So that's the only one that's different than its reciprocal. So the range for cotangent is from 0 to pi. The reason that it's different is because if you think about the graph for tangent and the graph for cotangent, they have vertical asymptotes at different places. So when you draw the inverse, the horizontal asymptotes are going to be different. So that's why the ranges are weird. Okay? So you wrote all that down. You got to memorize those 3 new ones. Okay? These 2 are really easy to remember. That one's a little bit harder to remember. Okay. So using reciprocals. So how would we use that? So basically you're finding cosecant inverse of 2. Instead of doing this, you can do the sine inverse of 1/2. So this is the answer. If you flip it, this was the answer for sine. So sine inverse of 1/2, you have to be in these 2, you have to be in this range, and then you think about it, you use the unit circle, you use your left hand, and then you get pi over 6. Same thing for b. The only difference for b is that this looks weird, but you have to realize this came from 2 over root 3. So if this used to be 2 over root 3, then you have cosine inverse of root 3 over 2. And then you think about, okay, where is that on the unit circle in quadrants 1 and 2? It must be pi over 6. For C, you have cosecant inverse of negative root 2. And then again, you think, what is the, reciprocal of this? And it's 1 over root 2, but we never see that on a unit circle. Oh yeah, you have to rationalize it. This is what we see on the unit circle. So now, where does that happen? Oh, right there. Okay, so that one I rushed through, kind of. Okay, the third one is, or the fourth one is the good one. So cotangent inverse of that. Okay, so where did this come from? A lot of people want to write this as a tangent inverse, but that's unnecessary. And if you do that, you'll probably mess up on something, and I'll tell you what. So instead, you just keep it a cotangent. So cotangent is this over this, but this came from 1 over root 3. And it didn't just come from 1 over root 3, it came from 1/2 over root 3 over 2. So really, this is what we originally had. It's a negative that over that. This is the x value, this is the y value, because cotangent is x over y. It's cosine over sine. So I used this part, and I said, okay, so this is either plus or minus 1/2, and this is plus or minus root 3 over 2. So where does this happen on the unit circle? Either in quadrants 2 or 4. For it to be a negative cotangent, it has to be here or here. And then cotangent inverse is from 0 to pi. So if you had changed this to a tangent inverse, you would probably choose this one, and that would be the wrong answer, because it's not negative pi over 3. It's going to be actually this inverse, the cotangent inverse, which is 2 pi over 3. Okay, and then the last part on a calculator. So if you have a calculator, and then you have the secant inverse of 3. Well, first you try without a calculator, and you're like, oh, that's the cosine of 1/3. And then you're like, oh, that's not on the unit circle. I can't do that. So cosine inverse of 1/3, you spit out an answer, and then you have to check that answer. So secant has the same range as cosine inverse. So it's from 0 to pi. Does this fit in there? It sure does. So then that's my final answer. But then the next one, that's when something weird happens. So cotangent inverse of negative 4 is the same as tangent inverse of negative 1/4. And then I put that into the calculator, and I get a negative. So the calculator's not wrong. They know that tangent inverse has to be in quadrants 1 or 4. So when they get that, it's going to be in quadrant 4. So they're right. This is totally fine. But my answer for cotangent, because this is a cotangent question, is supposed to be from 0 to pi. So if I want this to be from 0 to pi, I have to do something to it. What can you do to tangent or cotangent so that you're in exactly the same place for any degrees or radians? Oh, you can add or subtract pi. You can add or subtract 180. So you add pi, and then not 3.14, but the actual pi button, and then you get 2.9 radians. Is that between 0 and pi? Yes, that's less than 3.14, blah, 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 blah. So final answer. Okay, done. Ask your friends. Good luck. I will see you in a little bit.